Bug that isn't in your code. You write a scraper, you run it on your laptop, it comes back clean every single time. Pages parse, data lands where it should, nothing looks wrong. You push it to a server and within an hour it's throwing Fortin's count, which can be hours, or is stuck behind a captcha, or worse, is returning a real-looking 200 status with a page full of nothing. And the first thing almost everyone does is go back into the code. Reread the parsing logic, check a selector for a typo, wrap another block in a try except, and hope. 9 times out of 10, that's the wrong place to look, because the code didn't change at all. I've been running proxy farms and production scraping setups for a long time now. Real infrastructure, real servers, real targets that actively try to sort people from scripts. So this isn't theory to me. It's a debugging pattern I've walked through more times than I can count. And it's almost always the same shape. The code is identical between your laptop and your server. What changed is everything sitting around the code, the stuff you don't normally think of as part of the program at all. The network path is different, the IP is different, the concurrency is different. The headers a real browser would send without you even thinking about it are different from what your headless client sends. Scraping is one of the only kinds of software where the environment you run it in is genuinely part of the program's behavior, not just a detail. Think about how a normal API client behaves. It talks to a server. The server doesn't care if the request came from a laptop on your kitchen table or a data center halfway around the world. It just answers. A scraper is talking to something different. It's hitting a target that is actively trying to tell a person browsing with a mouse and a coffee, apart from a script fetching pages in a loop. And almost all of the signals that get used for that sorting are environmental, not logical. IP reputations, the shape of the TLS handshake, how fast requests come in and how evenly spaced they are, the order your headers show up in. None of that lives in your parser, so testing your parser locally tells you almost nothing about whether it will survive in prod. So when something breaks the moment it moves to a server, the first thing I check isn't the parser, it's the egress. The single most common reason a scraper works at home and fails in prod is that the IP sending the traffic changed character entirely. A laptop on a home connection is usually sending from a residential IP block, the kind that belongs to an actual internet service provider serving actual households. A cloud server sends from a data center SNN, a block of IP space that belongs to a hosting company. Sites that care about scraping keep reputation data at that SNN and subnet level, and data center ranges get flagged wholesale because almost no ordinary consumer traffic ever originates there. Your code didn't get worse overnight, your IP got worse the moment it left your house. This is easy to check and people skip it constantly. Take the exact same request, same headers, same code path, and run it from both places back to back. Don't just note it worked and it didn't. Actually compare the status codes and the response bodies side by side. If local comes back with real data and prod comes back with a 403, a redirect into a capture page, or a 200 that's technically successful but has no actual content in it, you've just isolated the difference to the network identity. The logic in the code had nothing to do with it. If you're already sending production traffic through proxies, the question changes shape a little. It's not just laptop versus server anymore, it's which proxy and what has that particular IP been doing before your traffic ever touched it. A shared data center IP that a dozen other tenants have already hammered with junk traffic is going to behave very differently from one that's fresh, even though on paper they're the same type of proxy. That's a maintenance problem as much as it's a technical one. A proxy pool with no health tracking will happily keep sending your requests through IPs that are already burned, over, and you'll keep seeing failures that look mysterious until you check per IP success rates. You want some way to track failure rates on each IP in the pool and pull the bad ones out of rotation. Basically the same discipline you'd apply to pulling a failing server out of a load balancer. It's not glamorous, it's just upkeep, but skipping it is how a pool quietly rots. Now say the egress checks out fine and it's still failing in prod. The next place to look is the fingerprint gap between what you tested locally and what's actually running on the server. If your local testing was done in a normal browser, or you were just clicking around the site yourself to confirm it worked, and production is running headless, you're not comparing two environments running the same client. You're comparing two completely different clients that happen to share a codebase. Bam. Headless browsers and plain HTTP libraries carry a fingerprint whether you intend them to or not. The way the TLS handshake gets negotiated, the order the cipher suites show up in, the extensions that get sent, The order and casing of your HTTP headers. Headers a real browser sends automatically that your script just never bothered to include. Even JavaScript environment details, things like navigator properties, that don't line up with what an actual device would report. None of this is exotic or hidden knowledge, it's just fine detail that a real browser gets right without anyone trying, and the script gets wrong by default, unless someone specifically closes the gap. The fix here isn't some trick, it's parity, plain and simple. Capture the actual raw request your production client is sending, headers and TLS parameters included, and put it side by side with what a real browser sends hitting that same page. There are tools that will dump a raw TLS client hello, or the full header set exactly as it left the machine, and once you have both side by side, it turns from a guessing game into a 5-minute diff. In practice, this is often something small and very fixable. Maybe your script is missing an accept language header a browser always sends without asking. Maybe your headers are arriving in an order no real browser has ever used because the library you're on picked its own internal ordering. Maybe your library defaults to a cipher suite that Chrome would never actually offer. Any one of these is a concrete visible gap once you've got the diff in front of you, and honestly it tends to matter more than which specific proxy you happen to root through. Separate from IP and fingerprint entirely, there's concurrency, and this one catches people constantly because local testing almost never exercises it. Locally, you run one request, you watch it succeed, you move on. In production, the same scraper is running across dozens of workers, sometimes hundreds, often all hammering the same handful of target domains at the same time. That turns the traffic pattern from one person browsing at a normal pace into a sudden burst arriving from one source. And that burst shape is exactly what rate-based detection is built to catch. Before you assume it's an IP quality problem, check it with real numbers. Log request volume per IP per minute in production, and look at whether the failures cluster right around the moments your concurrency spikes. If you find one proxy absorbing a wildly disproportionate share of your worker pool's traffic, that's a pool sizing and routing problem, not something a fancier proxy is going to fix on its own, no matter how good its reputation is. Saying concurrency limits per IP and enough IPs actually in rotation that no single one ends up looking like a traffic spike all by itself is just basic hygiene once you're running at any real scale. It's the difference between traffic that reads as a bunch of separate organic-looking sessions and traffic that structurally is a bot farm, because at that point, without those limits, it actually is one. Not every prod-only failure is about detection at all though, and it's worth ruling out the boring stuff before you spend the week chasing proxies. DNS resolution can differ between environments, especially if production is running inside a container with its own resolver setup. And a scraper that resolves to a stale or simply wrong IP is going to fail in a way that looks exactly like blocking, even though it has nothing to do with the target site. So denum fragments, clock skew on a production host is another quiet one. If the server's clock has drifted that can break TLS handshakes or break session tokens that depend on accurate timestamps, and the failures you get from that look a lot like a site rejecting you when really it's just a system clock that's off by a few minutes. Memory pressure under real concurrent load is another. A host under load can end up truncating responses, and the scraper that isn't checking for that will happily parse a partial page as if it were the whole thing. That gets misdiagnosed constantly as the site changed its markup, when what actually happened is the connection got cut short and nobody checked the response length. And then there's retry and backoff logic that never got exercised locally because you only ever ran one request at a time there. Under real failure rates in production, badly tuned retry logic can turn a handful of ordinary rate limits into a much bigger blocked window than it needed to be, basically making a small problem worse through the retry behavior itself rather than through anything the target site did. So when a scraper is failing only in production, the useful move is to change one variable at a time instead of guessing. Run the identical code manually from the production host and compare it directly against the same run from local. Check the reputation and the SN type of whatever egress IP is actually in use in each environment, not what you assume it is. Diff the raw request, headers, and TLS both against what a real browser sends hitting the same page. Log status codes and response sizes per proxy or per IP individually, not just one aggregate success rate, because a handful of bad IPs can hide comfortably inside an average that still looks fine. And try reproducing your production concurrency locally against something low stakes before you decide it's the target site's defenses and not just the shape of your own traffic. A scraper that only fails in production is almost always telling you something true, which is that production is not the same client the target site sees when things are going well. Sites that actually care about telling bots from people are reading exactly the signals that differ between a laptop and a fleet of concurrent cloud workers. Things like IP reputation, request fingerprint, and traffic shape. None of that means a scraper can be made undetectable, or that any setup guarantees you'll never get blocked, because nobody honest can promise that. It just means the failure has an actual cause, and that cause is almost always visible the moment you stop staring at the parser and start looking at what actually left the machine. I run the proxies behind real scrapers myself, and the full written guides along with the proxy setups I actually use are at proxyscraping.org, including this exact debugging walkthrough in more depth if you want to work through it on your own stack. Full written guides and tested proxy picks are at proxyscraping.org, and if this kind of breakdown is useful to you, go ahead and subscribe for more of it.